All right, you can see my screen, correct?
Correct.
All right, then thank you for the opportunity to give a short presentation about the current status of the client Times Cloud service, which is a joint project we are doing in cooperation with Canors and Decisionware. I will start with providing some background, basically recapitulating the motivation for this service. Then I will provide a little status report to inform what has been done in the project so far. And we will end with a live demo where me and Amit will give some examples on how to use the cloud service through different clients. What was again the motivation to suggest such a service to AdSap? We have been in touch with Times users and have been asked whether there could be a solution that gives occasional or potential future Times users a possibility to solve Times models without the need to purchase a GAMS solver license and without limitations imposed by free services such as Neos. And the purposes of these requests were manifold. For example, this was a lot of times about dissemination of results. And another obvious purpose would be to attract potential new users where license cost can often be a hindrance, and the cloud service, which is centrally administered and paid by AdSap, could of course contribute to lowering the financial entry barrier. What we've also heard was an occasional need of existing Times users to outsource certain computations to powerful hardware without needing to worry about licensing issues. And to address all those needs, we suggested a Times Cloud service at the December 2020 meeting that allows to solve Times models in the cloud. What are, again, the components and who are the players in such a service? There are, of course, the users who want to solve a Times model. Then there is the entire cloud setup consisting of hardware and a software stack, meaning the operating system, the technology called GAMS engine, which acts like a broker that assigns incoming jobs to available GAMS workers. And at the same time, this can also serve as a model registry, meaning that the admins can register, for example, different versions of the Times source code, such that only the data has to be shipped to the server when a Times model should be solved, because the Times source code is already there. And then there are, again, one or multiple service admins. Currently, the project partners GAMS and Canors are taking care of that. Now, how do these components and roles interact? To get access to the cloud service for the first time, users need to request a registration code from a service admin. Details about that will follow. And in addition to that, of course, the service admins take care of maintaining the software stack on the server. And now that the service is up and running, the user has gotten her credentials, the service can be accessed through different clients. We will see some of them in the short live demo. So to summarize the current status, the service is up and running. The underlying hardware is a dedicated server as agreed on in the proposal, and currently up to 8 jobs can be executed in parallel. Now, what are the next steps? We would, of course, like to get users involved to collect their feedback, and for the time being, no clear rules have been defined who is actually entitled to use the service. So for now, we do not see a reason to restrict it, and suggest that just anyone who is interested can request a registration code by sending an email to timescloud@gams.com. And of course, if AdSap has ideas to set up certain rules to define who should get access, we are more than happy to discuss that. We consider the Times Cloud service still in a beta phase, so we expect that the upcoming months will hopefully show an increased usage. At that time, we'll tell whether the service should be continued as is, or if there is a need for more flexibility or sophisticated solutions, like, for example, introducing per user quotas or going to the elastic cloud, meaning that instead of having a dedicated server that is running 24/7, instances could really be launched on demand, thereby increasing the parallel capability, but also introducing some complexity that we would need to deal with. In any case, GAMS Engine is a scalable solution designed to support these types of additional flexibility, and if we or someone else observes a need for that, corresponding adjustments can be explored within this project. Now I would like to give a short live demo showing how to get access to the service, followed by a few examples of different clients that can be used to submit jobs to the cloud service. The clients that I will show are GAMS Engine Web User Interface and GAMS Studio. And before going into the details, I should mention that using the web interface for job submission is a somewhat manual approach. So I'm not exactly sure if Times users will be using this option heavily, but this manual approach does nicely explain what happens behind the scenes when using other more sophisticated clients, like, for example, Veda Online or also the Times Miro app. With regard to Time, I will not show the Miro app in this demo. It's currently work in progress anyway. And I will also not show the code for any other custom clients, but I mention these options here for the sake of completeness. And actually, Veda is, for example, such a custom client. Now let me end the presentation so we can start the live demo. When you request a registration code, you should get an email similar to this one. You can just copy the registration code and click on this link, and that will bring you to the web interface to the Times Engine Cloud Service. When you see this for the first time, you click on register, paste your invitation code, and create username and password. So I just create a new account called @demo and choose a simple password, and I click on register, and now I'm logged into the Times Cloud Service. I'm not going through all the details of this web interface. It's in the documentation. What we see here is the jobs overview. Currently, it's of course empty because I just registered a new user. So what we want to do now is we want to submit a new job. And if we see the job submission page, we see that there are different namespaces. A namespace can be thought of like a folder where different users can get different access permissions. For now, we are interested in the Times namespace where models have already been registered by the service admins. So now we can select, for example, between different Times source code versions. So for now, I choose the latest 4.5.5, which has been released earlier this week. And now all I have to provide to run a job on the cloud service is that I need to upload data files. So for this demo, we are using the Times demo model, which is available on GitHub. Now, what are those data files? Those data files are the so-called DD files and, of course, the run file that has all the different Times command directives and defines the DD files that should be used for a run. So what I have to do, I just create a zip file, put all these different files into the zip. Or actually, I wanted to create a zip, not a RAR. And now I can use drag and drop to upload that zip file to the server. And in addition to that, I have to specify the name of the run file, which was demo12 run. And if you're familiar with GAMS, you could add any other GAMS command line options here. For example, let's create a GDX file called XXX. Click on submit job. We see that the job is running immediately, and this is a small model. So if we click on the job details, we see that the run has already been finished, and we can get a little log here. We see that we found an optimal solution, and we can, of course, download the results. Or let me just open this here. And there we can see that we have, for example, the GDX file that has all the 1,000 something symbols from the run, and that is then available locally again and can be used for further processing on your local machine. Now, what we see here is GAMS Studio, which is the common integrated development environment for GAMS users. And of course, this can also be used to run jobs locally. So what users usually do, I have now here the run file from the demo model, which I just uploaded. I can click on the green button, and now I'm running this on my local computer, solved to optimality in a little less than a second. But if I would not have a professional GAMS license installed, I could not solve this locally. And this is where GAMS engine comes into play because it is also nicely integrated in Studio. So instead of running locally, I can now select to run through GAMS engine. A little window will pop up. I will be asked to enter the engine URL, which is pre-populated. Usually from Studio, we submit to the default global namespace, and now I can use the account that I just created, enter my password here, and I can select whether I want to get a GDX file or not. And now I submit this, and we have the look and feel of a local run, but now we actually solve this model in the cloud. And we can see this if we look into the log. First, what we do is we compile the model locally, create some self-contained file that has all the source code and the data. That is shipped to the server. We see that we are switching to engine. Now we are running this on Linux because that server is a Linux server. My local computer is a Windows machine. We see that the ETSAP cloud license is used. The model is solved to optimality as usual, and all the related files, like for example the GDX, which I created by checking the checkbox, is brought back to my local computer, and now that should be exactly the same as the XXX GDX, which I created in the first example. All this is also explained in detail in the slides. There are a couple of links to documentation that will be shared afterwards. And with that, I would like to end my presentation, and I would like to hand over to Amit to show the veda integration of the cloud service.
Hi, thanks, Fred. So how do I share my screen? So you see my screen?
It's clear.
Yes.
Yeah. So, let's start with the local veda. Veda, yeah, for most of you, anyway, veda 2.0. So I've just used a small demo model, and on the run manager, you will see a new checkbox for the past few versions, which is GAMS engine. And if you have an ETSAP license, then this box will be active. We have to decide how to enable or disable this, but for now, that's how it works. So if you check this box and you select a run and you click solve, and then you notice here that it will say slightly different things. You know, it creates the DD files, then it says creating zip file to submit, submitting job, waiting for job to complete, downloading results. So all the steps that Fred has shown through that web interface are being performed by veda. And finally, what we get back is the big GDX file, and we do a local GDX to veda on the local machine so that we have all the VD files, and it's done. So basically, from a user perspective, you don't see anything different. And you will see the results where you see them normally with a local run. All you need to do is to check this box, and then instead of running locally, it would go to the GAMS engine and come back. So let me show you what happened. So this is the model input zip that was created with the DDs. So you see all these DD files and the run file that Fred had shown. So we create this model input, and then we get this zip as the download from GAMS engine. And then when we do the GDX to veda, we get these files, which are then a part of our regular workflow. So this is how it works. And just finally, I mean, if I disabled my GAMS license on this machine, this route would still work. So the GDX to veda basically works without the GAMS license. So that is how it works with Veda 2.0. Now, Veda Online must be new for most of you, but that is something very exciting which has come around very quickly in the last few months. So I will describe it in detail. Okay. I will describe it in detail during the expo, but very quickly, you can actually go and take a look yourself. LMA Veda I will put it in the chat, the link. But there is a fully functional website where you can access core Veda functionality through a web browser. So in that one, if you go into a model, it's the same model that we saw there, and you'll be able to see the items view, the browse like you have in Veda, and results and reports and all that is fine. But going to the run manager, which is integrated with the GAMS engine. Now, here again, there is nothing much to show apart from the fact that, that it really works. So if I selected this case to be solved and I click solve, then it tells me that the solve has been launched and will be notified by email. But actually, there is also you see this message below, solve is in progress. So this email system was what we had till 2 days ago, but now you can just wait on the screen and it says solve is in progress. And once the solve is done, it will turn green. And when it turns green, it means that the run has been done and the results have been imported into this interface. So it will just take 2 more minutes and then we'll be able to go into results and look at the results and reports and everything else.
Amit, just to say, there's 2 minutes left in the total 20-minute slot. So if we want to have some questions, just to let you know, okay?
Okay, yeah, actually, it will just say solve is complete, it will turn green and that's it. So from a user perspective, there is zero load in using the GAMS engine. Veda local and Veda online have managed it seamlessly. Yeah, so I'm done. You can open for questions.
Thanks very much, Amit. I should have said at the start of the session, there's a Q&A chat box at the bottom of your Zoom window. If anybody wants to ask any questions, please type them in. I see Iris from Scotland has asked a question. Thanks, Amit and Fred. Could you comment on the data security for using web servers? So I don't know, Fred or Amit, do you want to take that?
Yeah. I mean, that uses established communication protocols, so SSL encryption to send your data and download your data to the web server. On the server, we have a user management system, so you can, via access permissions, control which user can have access to what. So we can, and these are the security standards used are nothing that we had to invent. So we built on established technology there. So this is, of course, something that we had to take care of because this is a very crucial aspect also for a lot of other commercial customers. So yeah, if further details are needed, I'm happy to provide some pointers via email, but for now, I would say, yes, that's clearly something that we have been taken care of.
Thanks, Fred. Has anybody any other further questions before we move on? Pernil has a question. So can you comment on how the use of the cloud can you comment on how the use of the cloud will impact on the runtime or solver time of large models, please? I guess both of you have insight on that comment.
Yeah, I mean, if a large amount of data has to be shipped to the server, the speed of your internet connection plays a role. That's the first thing to consider. when it comes to solution time, meaning like CPLEX time, I mean, this is a powerful server, but of course, at some stage, we always will hit a resource limit. So what we have here is, I think, an AMD Ryzen 9 CPU with 12 cores, 24 threads, and the solution time will be impacted by how many jobs are processed in parallel, for example. So this is explicitly not a high performance computing project where the largest, humongous, super duper times models with hundreds of millions of variables should be solved, I think. So yeah, and other than that, the performance would be similar than just running it locally. But of course, you have to consider that other users might be using the service at the same time and compete for resources.
Thanks, Fred. I think also the type of model that Pineal runs with very high number of time slices and the amount of RAM on that server would be quite useful. Amit, do you want to comment on that question, or will we move on? Any further points?
Yeah, I think the advantage with this kind of setup would be in being able to do runs in parallel, not necessarily. So the running time of a single run may not reduce too much, but if we use the scalability that Fred had alluded to, and if we are set up like that and we are able to launch 10 runs in parallel, so that will be something which is possible, which is not possible locally easily unless you have a very large RAM.
Okay.
Maybe if I can add one more sentence here, James. This is something I mentioned on some of my first slides. Now we have a dedicated server that has certain specifications, and if we hit the resource limit, there's nothing we can do. We could technically also move that to the real cloud, meaning to AWS or Azure or something like that, where you can request resources for a particular job. But that gives you more flexibility, but that also adds complexity, because it's not so easy to come up with a flat fee for such a service, where you could, in theory, use all the instances that are available in the AWS cloud. So if it turns out that the service will be used in such a way that really big models should be solved, and a lot of big models should be solved, that's something that we are more than happy to explore in this project. But right now we are really limited to the resources of the particular server this is running on.
Great. Thank you, Fred, and thanks you, Amit. And I have other questions that I want to ask, but we're already over time, so we better move on. Really interesting, and I think that's going to be powerful when you start thinking about how you can collaborate in the cloud and solve in the cloud. It's going to be powerful stuff, so well done. We'll move on to the